Welcome to Spring LIB.
In this exercise, we're going to need the concepts of force and how to relate speed with acceleration. So I'm going to start by reviewing the concept of force, and then we can move on to the exercise. So according to Newton's second law, the sum of all the forces that act on a body is equal to the mass of that body times the acceleration. Also, according to Torricelli's formula, so this is Torricelli's, we know that the speed squared, the velocity squared of a body at any point is equal to the initial velocity squared plus 2 times the acceleration times the distance that was traveled by the object. And with these two concepts, we can solve our exercise. So in our problem, we have an elevator that has a mass m of 1 megagrams, and we have a motor that is connected to the elevator by a rope that's shown here in green. And the motor gives the rope a tension of 4 kilonewtons. And we know that the elevator starts at rest. Our goal is to find what is the speed of the elevator, v, after it goes up by 6 meters. So we have two steps. First of all, we need to find what is the acceleration of the elevator, and with the acceleration, we can find what is the velocity using Torricelli's formula. So first, let's find the acceleration using Newton's second law. So what I'm going to do is to draw a free body diagram on the elevator. So acting downwards, we have the gravitational force, which is m times g. And acting upwards, we have the force of the rope. Now notice that the rope acts on the elevator at 3 points. Okay, so there are 3 points where the rope acts on the elevator, and each point corresponds to a force of T. So in total, the total force that acts on the elevator is 3T minus mg, and this is equal to ma. So the acceleration is equal to 3T divided by m minus g. Now we know the tension, we know what is the force that the motor exerts on the rope, and that is 4 kilonewtons, so 4,000 newtons. And the mass of the elevator is 1 megagram, which is the same as 1,000 kilograms, minus 9.8 meters per second squared. So the acceleration is 2.2 meters per second squared. Then we can find what is the value of the velocity. So know that the velocity squared is equal to v0 squared plus 2a dx. Now v0 squared is 0. The acceleration is 2.2 meters per second squared, and dx is 6 meters. So v is the square root of 2 times 2.2 times 6 meters per second, which is 5.14 meters per second, which concludes our exercise.